So we're going to compute one more integral problem. Let's look at the following problem. I want to find the antiderivative of r prime of t equals cosine of 2ti minus 2 sine tj plus 1 over 1 plus t squared k. That satisfies the initial condition r of 0 is 3i minus 2j plus k. So the first thing we're going to do is find the antiderivative. We're going to find r of t. It's the integral r prime of t. So we're going to integrate each one of our component functions. The integral of cosine of 2t plus the integral of minus 2 sine t. And finally, our last component function plus the integral of 1 over 1 plus t squared times vector k there. So to get r of t, I'm going to integrate all of these functions. R of t, you have to do a u substitution for this one. You would get 1/2 sine of 2t I we'll do plus our first constant plus c1 I plus 2 cosine t plus c2j plus the integral of this would be arctangent of t plus c3 k plus c3k. So now I've found an antiderivative, but it needs to have those initial conditions. So when I plug in 0, and I'm going to plug in 0 in place of t, r of 0, well, sine of 0 is 0, so you just get c1i. Cosine of 0 is 1, so you get 2 plus c2j. Arctangent of 0 is 0, so you just get c3k. And I've got to find these constants here, c1, c2, and c3. Well, they told me that r of 0 was equal to 3i minus 2j plus k. So look at the equation that we have now. It says that these two vectors are equal, or they're only equal if their components match up. So if 3 has to be c1, negative 2 has to equal 2 plus c2, and 1 has to equal c3. So I've already solved for c1 and c3. I just need to solve for c2, so let's take that one over. c2 would be negative 4. So I've got my constants now, so I can write my answer, my vector. R of t, it was 1/2 sine of 2t plus c1, which was 3i, plus 2 cosine t minus c2 was negative 4j plus arctangent of t, and c3 was 1 plus 1k. And there's my antiderivative with the required initial conditions.